All right, so I want to start off with some demos. We talked about forms last time and how we get the information from a form. I want to run my server here and go to my HTML and see how that works in practice, play with the forms, and just look at the information so we can start to get a better feel and idea of how you're going to parse these post requests, how you're going to get this information. And as I mentioned last time, we'll almost exclusively, or at least I highly recommend, exclusively using the multi-part form, because you have to use that for files, as we'll see in a little bit. You have to use that for files anyway, so you have to write some code that's going to parse that. You might as well use that for everything and not worry about this URL encoding. But let's take a look at the other approaches and see how that information would come in case you come across that later elsewhere, or if you do want to take these approaches. So let's see how this information comes in. So first, I have my beautiful web page here, and I just want to show I'm printing out the requests and responses. I won't dig too far into my code, obviously, because a lot of homework solutions are in here. People will rewatch the video and just type it up, unfortunately. So, but I do want to show the requests and responses, and I'll explain what my code does behind the scenes. So I get the get/request. This is a homework 3. A homework 3 thing. So what you're working on right now, or have finished already. Get/. I want to serve my HTML, so I'm getting a get request for the slash. A lot of headers that I could look at, but for this case, I don't need to. I'm going to just serve up 200 OK, text HTML, give my appropriate content length, and then serve this HTML document. So I'm serving up my HTML and putting that in the body of the response. Now I have these UTF-8 characters, so I was very careful in my code to make sure that I have the content length as the number of bytes that are being sent, not the length of this string. So I'm not reading my file, creating a string, doing .length, using that as my content type. I'm taking the bytes, encoding this in bytes, and then sending that HTML. This HTML has a link to a style sheet. So when the browser reads this HTML, it's going to say, whoa, I need some more stuff here. It's going to send another completely separate request for get style.css. So whatever I put in this tag, it's going to request that from the path that it was reading the HTML from the same server, same port, same protocol, since I just gave a relative path. So it's going to say get style.css. I'm going to read that and say, OK, here's my CSS. It's only 50 characters. I didn't do much with the CSS here. I just turned the page into dark mode effectively, just inverted the colors. But just to show a second file upload. Then you would do the same thing for your JavaScript. So I hosted these two files on my server, which are my HTML here and my CSS here. I'm reading those files and then just saying serve this file, and then reading that file, doing the bytes and encodings and everything in a method, and then sending that. All right, so we're serving up these two files, and I have my method that says serve this file, and then I give it the content type. So in my server, in my util class, my util object, I have these methods, send text response, which is going to do the UTF encoding. I'm going to always have UTF-8 for this text, and I'm going to read my files, turn that into just one big string, and then give it the content type. So this is an HTML file. I want to say HTML. CSS, I want to say it's CSS. For this one that we'll talk about in a second, I'm just sending a raw string. I'm not reading a file. So I'm just sending plain text. So what we want to talk about now is this form. I have this form on my page, and I can see, you should all believe this at this point. Oops. But that file that I hosted is going to be, If I can even click right, man. It's going to be the same file that I hosted on the server. This, I believe this is all my ad block stuff, my ad blocker adding content from that extension, if you're wondering what all that mess was. Well, I blocked the ads on my own site, I guess. So I get that content over here. So we have this form. We want to focus on what happens when I fill out this form. So this is the first form that we saw in the slides. It's going to make a GET request with this information on there. I have commenter and comment. So let's fill out this form and see what happens. I guess I'll stick just with the lecture. Good morning. Submit. And what happened when that submitted? So I got a request from that form after my CSS. Did I reload the page? I must have reloaded the page, got more requests for my HTML and CSS. Another request. All right, and here we go. Since I have this as a GET form, it's going to send a GET request for the path that I specified in the action attribute. And since it's a GET request, it's going to put my entry into that form as a URL encoded query string. So I have commenter, which matches the name of this field with the value that I entered, and then comment matching the name of that field, of that input, mapping to the value that I entered, and URL encoded. So pluses for spaces to separate the separate values, and then percent encoding for any of the special characters. I had an explanation point in there, so that's a reserved character, so it's going to percent encode that. And just a quick comment, this came up in office hours, I forgot to mention it when I was talking about the homework 3. For your query strings, if you have very limited functionality for homework 3 on your query strings, that's fine. If you assume there's no percent encoding, I don't expect you to go through and manually decode the URL encodings. You'd have to have a lookup chart or something for all the percent encodings, convert those to the bytes. Actually, I guess that wouldn't be too hard, but yeah, it's just a little outside the scope of what we need to be doing in this class. But the URL encodings, you don't have to worry too much about that for homework 3. If you can take some strings and process a response and then send that response as those strings, that'll be okay. Any questions on that one? Anybody go down that road of decoding the URL encodings? Okay, hopefully nobody went down that rabbit hole. But I mean, it wouldn't be too bad if you had the right approach to begin with, but it's not something we need to worry about. There's enough content in this class. So I have this GET request. Then I'm going to send back just some response. So I did this in my code by checking if I have a GET request for a path that starts with form path. If I have a path that starts with that, then I know that I have somebody who filled out that form, and the rest of this path is going to be the query string. So this is where we would have our string parsing, look for the question mark, separate the separate key value pairs, separate the keys and the values, and then process that response. If you're storing that in a file, like the homework, or generating a custom response, whatever you're doing with that information, you'd be doing that here. I'm just sending back text saying thanks, and then not doing anything with that information I was got, just for the sake of example. Now let's change this to a post request. You know, I'm going to leave that as GET. So we're just going to send 404s back. But let's change this to a post. But importantly, one thing I wanted to mention with that. Oh, it already updated. You know, I can talk about it with the post anyway. One thing with this is we can see that we are making separate requests. These are just like clicking a link, just like entering a new URL. It's a request made to the server, and whatever the response is, that's what's rendered on the page. So we don't yet have forms that we can fill out, click something, and then just have that information update. So for example, if you have a chat app, which we'll talk about next week, if you have a chat app, you wouldn't want the page to reload every time you send a message. You just want that message to go to the chat and still leave your page untouched, unaltered. So this is important. What we're talking about now, it is always going to be a page reload every time we submit forms when we have them set up in this way. So we do have page reloads. But let's check out what happened when I submitted this as a post. We're going to get that next format that we saw in the slides last time. Okay, let me just scroll all the way to the bottom. So now we have a post. The path is just the path itself. We don't have query strings here. It's a post. We're going to have a content length and a content type. Somewhere in here, there it is. And our content type is this form URL encoded. So the user submitted a form, the browser URL encoded the response from that form and put it in the body of this response. And then we have 39 bytes to read from the body. So we're going to find 39 bytes right here. And we see the exact formatting, that URL encoding that we saw for the query string. It's just in the body of the body of the request now, instead of in the query string. So now we have to worry about reading that content link. We have to worry about the content type, which, I mean, based on your path, you can expect a certain content type, to an extent at least. But the content type and content length most importantly, to know how much information to read right here. Then our last step, our last approach, we had the encoding type. I didn't mention this in the slides, but there are only 3 possible options. The form URL encoded, that's the default option. Plain text, which you should never use. The internet agrees. If you search that, everything that I looked at anyway says don't use that. I don't know why you would use it. It's got problems. But this multi-part form data, this is the one we want to use to give us more flexibility, more functionality. So this multi-part form data, if we switch our encoding type to this and submit the same information. Oh, and by the way, yeah, we're getting content not found because we're hitting the else statement of my routing and just sending my 404 page. So my router on the else sends that 404 file. So if I didn't match any of my routing, any of my paths that I have coded in my server, I'm just going to send that 404. So I didn't update this to say if this is a post request for form path, do whatever. I didn't update that, so we're just going to hit my else and just serve the 404. So we're hitting that 404, which is our catch-all for anything that doesn't exist. But now that we have our form encoded, now we get a little bit more, dare I say, advanced formatting for what we're being sent. So now our post form path, this hasn't changed from the last one. Our content length got a lot larger, and we'll see why when we look at the body. Content length got a lot larger. There's a lot more information being sent to us. And the content type is now this multi-part form data. We changed that encoding type, so our content type has changed. So we have this different content type, and we have a second value here, a second key value pair, telling us what the boundary is between values in the body of this request. So now, when we look at the body of the request, when we start reading the content length number of bytes, we start seeing our information from the form, each entry in the form, as a whole separate section of the body of the request. So now we look at our boundary from the content type. We do have to read the content type at this point, at the very least to get this boundary. We're going to separate these values by the boundary. That's our delimiter. In the boundary, it looks like a randomish assortment of characters. The boundary is calculated by the browser to make sure that the content does not contain the boundary as a substring, so we can use this as a valid delimiter. So we don't want to use any special character. We don't want to just say the boundary is hashtag or the boundary is ampersand, because the whole idea using this multipart is that we can send any type of information. We don't want to restrict any characters. So the browser is going to compute on one of these requests this boundary to make sure that it's not a substring of any of the data that's sent. And they have the algorithms to be able to compute that fairly efficiently. So this is just what the browser came up with. And just to, actually didn't test this, so we'll find out together. I believe this boundary should be, oh, is it refreshed? Yeah, so that boundary is different each time. So it doesn't necessarily have to be, I suppose, but just the way the algorithms work, that boundary can be different every time. You can't depend on that boundary being anything specific. So you do have to read this from the content type. You have to get what boundary did my browser generate for this specific request. It's going to be different each time. Yeah, can be different each time. Yes?
Is the length of that string going to be different each time too, or is it just going to be?
Yes. I mean, not necessarily, but that's up to your browser. The browser just guarantees that that is not, that won't appear in your content at all. And I pretty much guarantee if I open up a new browser, I'm sure Chrome will, I should have tested this. This is dangerous territory, but I'm guessing that Chrome is going to give me a different algorithm. No, WebKit form boundary. So that must be a standard library. But there's nothing defining, nothing in the spec that says what that boundary has to be. It just can't be a substring of any of the data. So we do have to read this boundary, get this value, split our data based on that boundary. Split based on this boundary, and then reading each section of the body separately. And now each section of the body has its own subheaders. So this is where, what I was mentioning last time, it's really helpful to have a method that parses headers. Now when you're reading these subsections, you just throw the headers into your method that you have that takes headers, a bunch of headers as a bunch of lines and strings, and puts them in some key value mapping, some data structure that's going to have those. So you do the same thing here, and there's, for these ones, we only have one header for each. But we can have multiple headers. We can have a lot of information on each of these. So we have the header, which is going to tell us this is form data, but importantly, the name, getting the name of each field out of this. And then the body of the subpart of the body is the actual value from that form. And now we don't have any URL encoding. We have UTF-8, or at least let me just backtrack a little bit. Just to show that we have UTF-8, so we don't have to worry about that URL encoding, percent encoding, or any of that stuff. All that's off the table now. We have information that we can use just as is. Since we have those boundaries, we don't have to worry about any encodings getting in the way of our formatting. So we're highly flexible with this. We can send any bytes that we want in this format. So splitting on this boundary, not reading the last one, which will be empty after the last delimiter, parsing each header separately, at the very least to get the name, and then the body of each subpart to get the value. I highly recommend you write some methods to be able to parse all this. Take the body of a multi-part post request, give it the body, the delimiter, and have it parse all of this information for you and get the information that you're looking for. Writing that method will be helpful whenever you're working with forms. Any questions on this? Yeah. Yeah, so this is the same way as the top level HTTP request. We're gonna have all the headers, two new lines, so we have one blank line, and then the body. Oh, come on. And the body of the request. Except we're not worried about content length here, because we have content length in the HTTP header. We're gonna read that much information, and then once we have it, we don't have to ask ourselves, how much do we have to read in each body? Because we're just gonna look for the delimiter. That's the end, that's how we know how much to read. So we're not reading off the stream, we just have the body of the overall request already read. So no worrying about content length at this point. Any other questions? Yeah.
You were mentioning, like, use the phrase like spaghetti code for the upcoming homework after this one that's due on Friday. Is that the series of LSIFs, would you consider that like spaghetti code, or is that like some?
I mean that's debatable. So the question of how well organized should you be is my big block of else if is that poor design. It's debatable. I think the if else block should be fine. That's all you're routing to say which path should do what, but the body of each one of those conditionals should be nice and clean, in my opinion at least. Those should be clean. That you should be calling methods, offloading that work, and handling it that way. But at some point, you're going to have some big conditional block, which is going to do your routing for you. You can set this up the way a web framework would, where it would say, it would have methods to add a path and then give a function, and then that function is called when a request for that path is received for either get or post. You could set it up like that. I don't know how much benefit that would be for us. I don't think that's the worst part. Where you can really get messy code is in things like parsing the headers, getting the path and the request type, and pulling out that kind of information. That's where things can get really messy. Because if you're doing that separately for each path, it's going to be a huge mess. Like if you're on your cookie path, if you're saying, look for the cookie header, and parsing, going back to the raw request, and parsing, looking for that cookie every single time, that's going to get painful. But if you say, on my cookie path, run all my code that parses all my headers, parses all my information, and then check if I have a header named cookie, that'll serve you a lot better. Also, a method to parse query strings. I guess we might only be doing that once. Maybe that one's less important, but a method to parse query strings. Have an organization like that. The if-else block, I think you can get away with. I mean, obviously, I think that because that's what I did. But if I sat down and really looked at my design there, it's not the first place I would look to improve. Maybe I would. Now I'm thinking of how I can reorganize that. Maybe I would improve it. Let me get back to you. If I have some time to sit down and reorganize that, I might hit you up with what I come up with. Yeah, Alex.
For homework 4, should we do all our submits with post, or is there something yet? I know something specific.
I'd recommend to do them all with post and all with multi-part. Then you only have to write that code once. For objective 1, you could get away with either get or post without multi-part, but then you got to worry about the URL encodings and things like that. Once you get to objective 2, you have to use multi-part anyway. You're going to write that code, so why not reduce your workload?
With objective 1, is it okay if we start that file back and just print it out?
Yeah.
Instead of HTML?
Yeah, for the file in objective 1, I was thinking just a CSV file would be fine. To pull out the 2 values from the form that you get sent, and then put a comma between them and put them in the CSV file. I'm not looking for any fancy formatting or anything. That doesn't have to be HTML. The objective 4, that's where I'm hitting you with the HTML templates. Objective 1, you shouldn't be worrying about that quite yet. Or you don't have to be worrying about that quite yet. If you want to make it fancier, by all means. But that's not a requirement. You can just store it in a CSV, send it as plain text. Yeah, in production, that's where you would read the CSV, parse it, and then go to an HTML template and make like a table with all of that data, you do things like that. We don't need to do that quite yet. I'm worried about that functionality. How do you get that functionality? And then we could make it prettier at some point. I'm not too concerned with it. Can you get data from a form and host it? That's what I'm concerned with now for objective 1. All right, let's talk about some file uploads. So just a quick review. We just went through the examples, so I guess I don't really need these slides right now. But we had this multi-part encoding to be able to get that better, I'm hesitant to say better, but that more flexible way of getting information instead of using those query strings. Then we got information like this that we just saw in the slides. I did use the same exact message. I thought I said hello last time, but anyway, good morning. I'm consistent, if nothing else. So this multi-part is required for file uploads. This is why I say you have to use this. You cannot upload a file without using multi-part forms. So if let me go one more slide. So we have this multi-part form, and then if we want to upload files, we change the type of an input to file. And that's it. For the front end, obviously there's a lot more work we'll have to do on the back end. But for the front end, that's it. Type equals file, done. Front end's there. So let's take a quick look at what happens if we don't use this multi-part. I have it as a bullet in the slides, but just to really make the point, I changed this to file, upload. I really have to change all my names, but I feel like it. Form file. Go back to my server. Enter my name. And now since that's input is type file, I get this choose file button. It's going to open up all my files, and I get to choose exactly what file to upload. I'm going to upload just some text, chat.js, submit. That's, not this file. It's somewhere. I'm not going to dig up that file, but it's some JavaScript, trust me. When I upload that, I'm using this form URL encoded. So all of the information from the form is in the body, and all I get is the file name of that file. Not very useful information. So if we don't use the multi-part, all we can upload is the name of the file. What are we going to do with that? We cannot get the information. The browser will not send the information if we don't use the multi-part. If we use a GET request, it will not send the information. It'll send the same thing, just the file name. So we cannot use this for this purpose. We have to do encoding type multi-part form data. Once we do that, now we still get the file name, we get the name of that field, we get this name, we get the file name, we get a content type now to tell us what kind of information was uploaded, and the browser's going to handle this for us. It's going to look at the file and try to figure out what it is, and all the content of that file now. With multi-part, we actually get the file. We get the bytes of the file, which is what we're interested in. So when I say you have to write this anyway for Objective 2, you literally have to write it. You can't do file uploads without doing some, actually can you? Is there another way? I don't even know if there's another way to do this with JavaScript. There shouldn't be, to be honest. It should be the only way to do file uploads. If somebody wants to hold me to that, I wonder if there is. But it's in there, so now to think about that, this should be the only way to do file uploads on the internet, through a browser, anyway. So we change the input type to file, use our multi-part form data, and go that way. Yeah, I won't go on this tangent too long, but has anyone uploaded a file without a page refresh? I've never paid attention that much to it. I think every time you upload a file on the internet, there has to be a page refresh, right?
You can submit it using JavaScript. It will have the same doc type. You can submit a file using JavaScript and it won't refresh the page right now.
I'd like to look at that someday. I'll have to look into it, because JavaScript can't read files off your file system, so how does it get the bytes to begin with?
You still select it like that, and then you can actually access that file.
I see, okay. That makes sense. So, yeah, so the input is still reading the file and then giving it to JavaScript. That makes sense. Thank you for that. Yeah.
Can you only upload a file inside of a form? You can't just decide?
I believe you can have this input outside of a form. I have it inside of a form, so when I click submit, it's going to send all of the inputs within that form element to the server. I believe you can have that file input outside of a form, which is what you would want to do in that case if you want JavaScript reading sending the file, handling that file data. But it's important for JavaScript to not be able to read your files, or else every website's just gonna, not every website, but some websites you click are going to start reading your file system, stealing all your information, things like that. We don't want that. So, but yeah, so you hijack the input of type file, so you still have to select your files and go through that process. That makes sense. I'll go with that, but let's move on. I don't want to get sidetracked too much. So when we post this, we're going to get what we saw in the server. We're going to get the information in this multi-part, in any part that's a file. We're going to get that file. We're going to get the file name. We're going to get the name of that input from the form, the content type determined by the browser, and all of the bytes of that file. So all of that information that we've read from that file. And now at this point we could save that file on our browser for Objective 2, on our server. For Objective 2, we'd read those bytes, write those bytes to a file, and then we could start hosting that file. Was that? Okay. And we gotta talk about encodings again. So there's a common thing that I'll see in office hours next week, almost guaranteed, is when we get this file, we're getting the bytes of the file. Now, so far, whenever we've gotten bytes like this, we've decoded them immediately. We want to work with them. We're usually getting a string, so we hit decode to get it into text string instead of the bytes. But if we think about what we're doing here, we're getting the bytes for a file. So for example, we're getting an image for the homework. We're getting the bytes of that file. Those bytes are not UTF-8 encoded. So we can't turn this into a string. We can't work with it as a string. I mean, we can, but we're going to get errors and nothing's going to work right. So we can't work with this as a string because it's not UTF-8 encoded. It's not ASCII encoded. It's not encoded using any text encoding. It's encoded using whatever format it is. So if I send a PNG, it's going to use PNG's encoding. If I send an MP4, it's going to be an MP4 encoding. That's how the bytes are going to be encoded. So we don't want to decode these as UTF-8. We're just going to get a bunch of garbage on the screen if we print it out, and kind of a garbage file if we save that. Because the decoding, it won't be valid UTF-8. So what we want to do is actually less than what we've been doing. We just want to work with the bytes directly. If we want to upload a file, have our users upload files and then save them on our server, we just take those bytes right from the TCP socket and write them to the file. No encoding, no decoding. And for homework 3, when you're sending your image, don't encode it before you send it because that's not UTF-8. Encoding that with UTF-8 doesn't make sense. It's already in bytes. You read your image, you read the bytes, you send the bytes. And the tricky part to that, which a lot of you are probably finding out, is you have the headers, which are text. You have your file, which is bytes, and you need to concatenate the two. So when you write your headers and your response line, you want to encode those in UTF-8, get those in bytes, and then concatenate those bytes to the bytes of your file, and then send those bytes over your stream. We have to be aware of how these encodings work. That's why I spent so much time on it earlier. We have to be aware of these encodings work, because when we're mixing encodings in our responses and requests, we need to be aware of what's happening at the byte level, so we're not using the wrong encodings in the wrong spots. When it's text, that's when we encode and decode using UTF-8. But when we're handling multimedia, when we're handling images, videos, etc., we want to handle those in just the raw bytes of the file. We don't want to change those encodings. Those encodings are handled elsewhere. The browser is going to implement PNG encodings and render the image in MP3s and stuff. Our server never has to read these files. Our server never has to display an image, for example. All it has to do is send the bytes to the browser, and the browser will display the image. So we're just working in raw bytes when it comes to this multimedia content. We don't have to care about the encodings at all. Just moving the bytes around. That's what we're concerned with. Reading bytes from the body of a form upload and saving them to a file, reading from a file and sending the bytes in a response. And that's it. And the content length is just the number of bytes. You'll read the files as a byte array. You'll get the information from the request as a byte array. Byte array.length, that's your content length. And keep it kind of simple. It's simpler than working with strings, but since we work with strings already, there's a tendency to want to use the encode and decode to apply UTF-8 to the raw bytes. We have to do actually less for the files. Sometimes you do more work and it gets you in trouble. So just a heads up about all of that, which does apply for homework 3, so just be aware of all that. Yeah, bugs and headaches, if you do. All right, quickly, I'll probably revisit these. This is very important, so I'll probably revisit these on Friday before we talk about HTML templates. HTML templates shouldn't take the whole lecture, so we can talk about buffers for a bit too. But buffers, just a quick intro. When a user sends information to the server, they're going to send information over the TCP socket. And no matter your language and library, these slides are going to apply to any library that you have. And I know I'm going to regret saying that because somebody's going to be like, my library handles this for me. But any library is going to have this functionality somewhere. You're going to have some way to run your code when data is read off of the socket stream, whether it's a read bytes method, whether it's Scala when I'm getting a message of type received. Some way you're going to read information off of the stream and execute your code that's handling a request and then sending back a response. Somewhere that's going to happen. So what's happening when this is called? So when we have bytes arriving on the socket, if you have, for example, a library that has a well true and then has a received method, you're going to read the bytes and then process those bytes. That received method hangs. It just sits there until there's information to be read. Then once there's information on the socket to be read, it'll read it and then return that information. You're going to get those bytes. You're going to decode it, read the headers, figure out what this request is for, and process it however it needs to be processed. So what happens when the user has a lot of data to send? How do we handle this? And I realize every bullet point I wrote for this slide is all just questions. It's more and more questions. So what happens? User has a lot of data to send, or has a slow connection where it's not a lot of data, but it's coming in really slow. What if this is a stream? What if the user's uploading live video? Like on Twitch, what if somebody's just uploading live video and the stream never ends? It's a poor example because that's a separate, there's a lot of HTTP requests, it's not all one request. But what if there's a lot of information to be sent? over the server? What if somebody's uploading a movie to the server? What does our TCP socket do? What does that receive method do when it's trying to read bytes off of that socket stream? What is it going to do? How does it handle this situation? And the answer is buffers. So it's only going to read, once there's information to be read, once information gets here, the server has information to be read, it's going to read at least some of it. Now, and it's going to read usually, at most, a few kilobytes of information, if it's there. And if this is a slow request, if the client is just taking a long time to send that request, it won't necessarily wait for that whole buffer to fill. It won't wait for a few kilobytes of information. It'll read whatever's there and ready to be read so we can start processing it. The server, the TCP socket, is not going to sit there and wait for the entire bunch of data, like from the previous slide. What if it takes an hour and your server's just sitting there waiting and waiting for information when it could be processing streaming video? What is it going to do here? So it's just going to read a few kilobytes at most. And sometimes even if you have fewer, less than a kilobyte, you can still only get a partial request in some cases. So this is where buffers come in. So that's a buffer. We have a few kilobyte sized buffer in our TCP socket. So what happens when somebody's uploading a megabyte file? So with GET requests, and so far in this course, we haven't had to worry about this because all the requests that we were sending fit in the buffer, and there was no slow connection because it's all on your same machine. You're not going to have network lag or anything like that when it's all on your laptop. So what happens when we do have these problems when for homework 4, we're uploading images and you have more than one buffer full of bytes to be read? This is where we have to be aware of these buffers. These are going to come into play strong for homework 4. So you're not going to be able to read the whole request in one shot. For your homeworks, I'll be fine if you assume that you can read all the headers in one shot. So you can assume that all the headers are there in the first time that you call your receive, the first time that you receive bytes off of the socket. Assume that you have all the headers. I'll consider that a safe assumption for this course. It's not always true in practice, but I'll assume it's a safe assumption for this course. You read the headers, read that content length to figure out how many bytes you have to read, and then keep stitching these reads together. Keep calling read in your infinite loop. Keep piling those bytes into one large request, and then once you read content length number of bytes, that's when you can finally process the request. So if we have that megabyte image being uploaded, we're going to keep calling read on our TCP socket server, keep adding those bytes to this request that we're reading off of the stream, and then once we read content length number of bytes, now we're ready to process. Now we can handle this request. And then do whatever we need to do, save the file on the server, send a response that says thanks for your image or whatever. But that's when we would handle that. So we do have to worry about these buffers now. And we'll revisit buffers. That was just a quick intro. We'll revisit buffers on Friday and then talk about HTML templates. See everyone Friday.